What's up guys, it's the Unhinged Engineer here, and today I want to start hopefully the first of many videos reviewing books that I've read related to engineering that I really found interesting and got a lot of value out of. If you're interested in AI/ML stuff at all, you're probably well aware that we're in a bit of an AI race between the United States and China. There's lots of geopolitical tensions surrounding not just the proliferation of AI applications, but also AI hardware, specifically GPUs. And the foundation of GPUs and just about any other aspect of compute are semiconductors, right? When you try to find content about semiconductors and about all the politics surrounding them, it was difficult to find, I think, content that I could really consider empirical, because obviously lots of different people have lots of different opinions about these different dynamics between countries and obviously the countries involved. Of course, as an engineer, I was looking for something a little bit more technical and a little bit more surrounding the history of this technology and why the world has become the way it is in regards to GPUs and semiconductors overall, regardless of how we feel about how it is, right? And I don't think any book serves that purpose as well as Chip War by Chris Miller. And so that's why I wanted to make a video about it. I really enjoyed this book. It's about 350 pages long. I actually was able to read it in Japan, which was pretty cool. And Japan is a large part of the book, as we'll get into in a moment. But this book really talks about the entire history of semiconductors, from start to finish, starting in the 50s, right after World War II, and coming all the way up through the present day. And so it highlighted lots of aspects of history that I didn't really know, even throughout the course of my working experience in this area, which I'll share with you guys in a minute. But even throughout the course of my work experience, I didn't really know a lot of the lore behind how the world of GPUs and AI hardware got to be the way it was. And this definitely enhanced my ability, not just to do my job, but also to understand why my job exists and some of the ramifications of what we're building. So speaking of that job, this is actually the role I held previously, before the one I currently work. I was an AI researcher at Carnegie Mellon for 2 years. I specifically focused on GPU performance optimization. Lots of low-level C++ programming to make these models go burr on resource-constrained hardware. Because a lot of AI is really easy to do when you have a massive data center or unlimited AWS credits. And when you have really shitty microcontrollers in the middle of the desert, it becomes a lot more complicated to actually deploy real effective AI/ML applications. So that was what I worked on for the better part of 2 years. I really enjoyed that job. It was my first one out of college. And so I feel like I know a thing or two about the technology that this book discusses. However, I did not know a lot about the history of this technology, and that's why I want to talk about this book with you guys. So let's just get right into it. So this book has about 8 parts, spans 350 pages, 54 chapters total, I think, which sounds like a ton, but it's really tight. There isn't a lot of beating around the bush. While there were, I think, 8 or 9 different parts of the book, I want to break it into 3 main themes that I found. So the first one here, I'm effectively just going to call the Inception of Semiconductors. And this is mainly going to take place in the US and specifically in Silicon Valley. And Silicon Valley at the time had a very strong military leaning. If you're my age, in your mid-20s, when you think of Silicon Valley, you think of commercial technologies like Facebook or Google. But the history of Silicon Valley with companies like Texas Instruments or IBM or Intel, a lot of the work they did was military in nature. And that's actually the subject of another book that I definitely make a video about at some point. But the military was effectively the first use case of integrated circuits at all. And later on, this primarily military technology was commercialized, as we obviously know, considering the fact that I'm recording this on an iPad, right? Beyond that commercialization, it actually talks a lot about the companies that were founded during this period. If you've ever heard of the Traders 8, it was actually 8 guys that left Fairchild Semiconductor to found their own companies, some of which I just mentioned. So very interesting section on the inception of semiconductors and the birth of Silicon Valley, all very nascent, obviously. Just to kind of highlight a really cool story, I'll try to highlight a cool story from each meta section of the book as I define them. There was a really interesting story about a bridge in Vietnam. So if you imagine, the military had data to support the fact that bombs, when dropped from aircraft, typically landed within, I think, about, on average, 420 feet of their target, give or take. And these are all figures that are in the book. 420 feet, which effectively means if you draw a normal distribution around a circle of a radius with 420 feet, effectively 50% of your bombs are going to land within the circle and 50% are going to land outside of it, right? which obviously is not a good, it's not really good. But something that this book does that's really interesting is kind of give like military context to those numbers. First of all, immediately means that hitting any kind of vehicle dead on is virtually impossible. Because even if I know where my target is with perfect accuracy, and that's a giant assumption, even if I know where my target is with perfect information, and I try to hit it, the odds that I actually hit something this small are very, very limited. It's not possible to just be like, hey, I want to take out that vehicle. Similarly, as the driving example for the story here, there was a bridge that I was referring to. In the book, I believe they said this bridge was 540 feet long. So this bridge was actually really, really important to Viet Cong's shipping routes for military equipment. When they're moving, ammunition and weapons and soldiers around, they would use this bridge a lot. And so America knew that if they knocked out this bridge, it would pose a serious logistical challenge for their adversary. To give context to that number I just disclosed, you can't hit this, right? Like you can't reasonably hit this because, radius around it of uncertainty is too big. They effectively dropped dozens of bombs they would drop on this bridge and they could never hit it. Despite knowing the target, having good intel on where the target was, they just couldn't hit it because they're not accurate enough. They went to Texas Instruments, which, by the way, if you're my age, when you think Texas Instruments, you think like the TI-84. They obviously did other things, including laser guided missiles. Texas Instruments, with about like $100,000 of funding, came up with a laser guided bomb concept, right? Where you would shoot a laser at the target and then you would have closed loop control of that bomb going down towards it. And they immediately knocked this thing out first try. And the point of this story was that it was the first deployment of weapons with integrated circuits with compute on board that had ever been done. Previously, a lot of these kind of bombings and like missile deployments would be ballistic. So you would do a bunch of math, you would set up the initial conditions of the rocket. In other words, you point it at the thing and you would let that thing rip. And if it hits, it hits. If it doesn't, it doesn't. At that point, it's open loop control. And so this example was really, really cool to me because it was like one of the first examples of closed loop control in this kind of context and really provide a lot of context surrounding the numbers and how these engineering challenges actually manifest themselves in military operations. So that was super neat. Lots of really cool stories like this in the book, but let's actually get to the next section. I'm gonna call this section Corpo Wars. If you've ever played Cyberpunk, you know what I'm talking about. Effectively, most of this chapter surrounded Japan and the United States, which is why I was saying it was cool to read this book in Japan. Japan had reindustrialized since the Second World War, and we were not in a military conflict with them, obviously. This was an economic and industrial adversarial relationship, right? So there's lots of companies in the United States, like Intel and IBM, Texas Instruments, aforementioned, and lots of competition in Japan, like Samsung and Sony and Panasonic, Motorola. All these different companies kind of is reminiscent of what we're seeing between American and Chinese companies in the modern day. A lot of this actually surrounded memory, specifically DRAM. It seemed like Japan had kind of taken a lot of the manufacturing lessons they actually got from the United States and used it to manufacture computer memory at a scale that had just never been seen before. And this is very similar to like the automotive industry. There's a reason JDM cars exist in that golden age of sick-ass sports car like the R34 Skyline happened, right? It's because they took lots of manufacturing lessons from the United States and from the world globally, and they used it to scale up manufacturing of different products like cars, computer memory, really, really high. In addition to that, it did actually talk about two kind of military-esque conflicts, the Cold War and the Gulf War, which I thought were very fascinating. Specifically, the second one was very, very fascinating. Right. In terms of the Cold War, like a lot of the conflict was surrounding kind of hard power technologies, mainly nuclear bomb. It was all about, pointing bigger guns at each other. And it was a little bit less about information warfare than what you might see in, our current conflicts with China. But the Gulf War concept I thought was really, really interesting because A, I was just less familiar with the history surrounding it, but B, it again gave military context to engineering challenges. So getting into the Gulf War, it obviously sets the context with the invasion of Kuwait by Saudi Arabia, and then conflict with Saudi Arabia by a coalition of nations kind of headed by the United States. Talks about precision strikes on key points of infrastructure within Saudi Arabia, which again was something that was not really executed on a large scale in a real military conflict much up to date. Bridge in Vietnam was kind of the first example of it, But between that time and the Gulf War in the 90s, it had never really been executed on a large scale. And now when we think about military conflict today, that's kind of the first thing we think about, is immediately using precision weapons, either kinetic weapons like bombs or missiles, or even like non-kinetic weapons in the modern world like lasers or RF jamming, stuff like that, to knock out key points of infrastructure. And so this is something that was done under Bill Perry during the assault on Saudi Arabia for kind of the first time. By the way, just to cite a number in here, it says that the missiles and bombs used were 6 times as accurate by the time that the Persian Gulf War happened than they were in Vietnam. So again, getting back to that whole MOA concept, right? You're able to hit precision targets with much higher reliability, especially if you think about the fact that you're invading like a city or something and there might be civilians around or structures that you don't want to hit. It's really, really important to know when your requirements do or do not close, specifically your engagement requirements, not just your engineering requirements, right? The last part I want to get out here, China, for lack of a better word. I wrote this as like the rise of China, not just CCP, but also Taiwan and the company TSMC. So TSMC, obviously like a heavily state-backed company, Taiwan Semiconductor Manufacturing Corporation, very, very relevant to the larger conversation surrounding GPUs today, like GPUs and AI. Part of what I liked about this book was that this part of it doesn't actually come up until the final third of the book, which I thought was really, really cool. I didn't know a lot of this history, and I'd heard of this history nominally. I didn't know it as well and in this much detail as the book goes into. And so there's lots and lots of stuff here you're probably much more familiar with if you're younger like me and you're familiar with the geopolitics surrounding GPUs and AI/ML applications, how TSMC came to be, kind of China's rapid technological development and some of their strategies surrounding that. So something I found really, really interesting in this book hadn't actually happened at the time it was written. So it's not explicitly mentioned in here. But one of the chapters is called China's Sputnik moment, and specifically talking about the movement towards EUV technology, which is a specific kind of lithography used for like taping out silicon. And so they referred to like certain developments made during COVID as kind of China's Sputnik moment. Now, if you know what I'm referring to by Sputnik here, Sputnik was the first satellite that Russia put up in orbit. They did it before we put anything in orbit, and so obviously it was a big oh shit moment for the United States that led to the acceleration of the Apollo program and ultimately our landing on the moon, right? What's funny is that they kind of were referring to like some smaller technological developments as China's Sputnik moment. What I really interpret to be China's Sputnik moment, and I say that because I was at Carnegie Mellon at the time that this happened, was actually the release of Deepseek. Deepseek is like a LLM that was released in China, was trained on hardware in China. It was made open source. That, you could download all the weights, but there was also an application that would run on Chinese servers that you could use. Deepseek was the first of Chinese models really competing with American models by companies like Meta and OpenAI and Anthropic at a large scale. And they actually leveraged lots of really, really novel techniques related to quantization and other things that really was an example of Chinese AI applications catching up to American ones. And so this whole book, along with a lot of the discourse surrounding this, is under the assumption that the quality of applications that we're going to be able to write and run, like AI applications, is a derivative of the quality of hardware we can use to run these applications in their final form and also develop them on the back end. And so this was the first example of that kind of implicit assumption of engineering really being correct. China was actually building models comparable to United States models using things like distillation and extreme quantization and stuff like that. So honestly, scary moment at my previous job that I think like there was kind of a hole in this book where it was released in 2022, but Deepseek was released in about 2023, like their first model. Deepseek's a company. But yeah, this is like my overall kind of executive summary of the book as I interpret it. And again, this video, I'm really just trying to review the book and talk to you guys about it, hopefully in an attempt to either A, teach you something, but B, convince you to read this book, because obviously that's the first source. So yeah, now that we've summarized the book overall, I guess we should talk about some of the lessons, themes throughout the book. that I thought were really, really cool. I think the first one was really stressing examples of hard versus soft power. And if you're not familiar with this theory of political science here, hard power is effectively power exerted through coercion. So like, I'm going to beat you up if you don't do this, or I'm going to punish you in some way, right? That way could be economic. It could also be military. Hard power versus soft power is power through influence, slowly influencing or even persuading someone or an organization to do something that it may not have wanted to do initially. And the point that I thought was really, really interesting about this book is that when you learn about engineering, everything is very causal. Even in non-deterministic fields, we're learning about causal relationships between different things. A leads to B leads to C. And so when we learn history, and especially when we as adults, as working engineers, look back on the history we learned, it's very much like, the independence of Scotland. Like there's a castle in the middle of the United Kingdom, and as England takes over the castle, and then a bunch of Scottish guys run up and take over the castle by force, and then they hold on to it for a little bit, and then 100 years later, England comes back and takes it back from them, right? And just back and forth, back and forth. Like this is a very simplistic way in which we learn history as children, but the reality of the situation is that things are much more complicated than that. Not everything, especially in the modern world, is done by force. A lot of times. And so touching on those kinds of concepts while also maintaining focus on technology was super, super cool to see in this book. The next point here I thought was really cool. I'm going to call the munchies, right? If you've ever eaten a bag of munchies with all the different types of chips in it. GPUs. What does that really mean? GPUs have logic units, GPUs have memory, they have I/O, different form factors, lots and lots of different things surrounding that hardware. And that's just one type of hardware, right? There's FPGAs, integrated circuits, microcontrollers, quantum computing, all these different things. When we think about geopolitics, politics as a whole, but it's geopolitics in the context of this conversation, a lot of times we simplify the conversation to be about one thing. And the reality is computers as a term is not very useful because at this point, there are so many different kinds of them. Maybe when all that existed was the integrated circuit invented by, what was his name? Jack Kirby? Kilby. Yeah. Kirby drew comics. Jack Kilby, excuse me. Jack Kilby. Maybe back then when there was 3 types of integrated circuits, it made sense to talk about computers as this monolith. But in the modern world, that's not the case. There's lots of different compute platforms and they vary in different ways. They vary in form. They vary in function. They vary in manufacturing processes. They vary in customers. They vary in supply chain. Lots of different stuff. By the way, function can again be broken into military and commercial. Lots of different ways in which these things all vary. And so to just treat them like a monolith is definitely an oversimplification that I 100% did despite actually working in this field, which is, kind of striking to me in hindsight. A couple other points here. This book taught about a lot of great men. If you've ever heard of the great man theory of history, which is definitely an interesting theory of history, but nonetheless, this book kind of subscribes to, that as far as I can tell, and talks about lots of really interesting and influential figures like Bob Noyce. Morris Chang, the founder of TSMC, was somebody I'd never heard of before that was really interesting. Akio Morita, founder of Sony, and then a million world leaders. Reagan, Gorbachev, Khrushchev, yeah, lots of different people, characters in this story that I was not familiar with. That was super cool. The last thing I want to talk about here is really a good definition of a military-industrial complex. So if you're like me, when you think of a military-industrial complex, you really just think of the military part. But the reality of the situation is there's the military part, there's the industry, the companies and people that build technology used by the military, right? And then there's the complex part, the different funding vehicles, different procurement processes within both the government and within the performers on certain contracts. There's lots of different complicated systems surrounding the military-industrial complex. Point being that it's not really a binary thing. It's not a binary thing to say that this company is entirely commercial or this company is entirely military. For some companies, that's definitely the case, or some organizations, that's definitely the case. Obviously, the Pentagon is a purely military organization, duh. But certain organizations and certain parties within the global supply chain of semiconductors and whatnot it's not as clear. Like a great example of this would be like TSMC. TSMC, I think they said in the book, I can't actually remember, it was something like 40% of the company was owned by the Taiwanese government upon its inception. These are all really interesting questions about what a military industrial complex actually is and actually isn't. And so this book really examines that question in an interesting way. Okay, well, this was almost more like a podcast than a book review, but I do hope you enjoyed it. Like I said in the beginning of this video, I really enjoyed this book. I think for anybody interested in this kind of technology and interested in the ramifications of this technology around the world, this book is definitely worth giving a read. So I'd highly recommend it. Again, Chip War by Chris Miller, super cool book. And yeah, this is probably the first of several book reviews I want to do. I've read lots of really cool books about not just the practice of engineering or even professional development within engineering, but other kind of peripheral stuff, peripheral to this channel like this. So if you found this kind of content really interesting, definitely let me know, because I'm more than happy to make more videos like this. But I definitely 100% plan to review more books like Chip War. Thanks a lot for watching. Like I said in the beginning of this video, I'm the Unhinged Engineer. I make professional development content for young engineers like me. And so if you're interested in that kind of content, or my grad school vlog, I'm going to Georgia Tech at night while I continue to work full time, or book reviews like this, I'm running out of things, then definitely like, comment, subscribe. Thanks a lot for watching, and I'll see you next time.